Hello students, welcome back. So far I was doing angular momentum operator and we have calculated the eigenvalues for angular momentum operator. We have seen when L square operates on the eigenstate Lm, you get the eigenvalue L plus 1 h cut square. Similarly, when Lz operates on Lm, you get eigenvalue mh cut Lm, and when ladder operators operate on the state Lm, we get eigenvalue L plus 1 minus m plus minus 1 h cut L m plus minus 1. So now this state Lm is abstract states. Now I want the position or coordinate representation of this state. That means I want the functional form of this state. For that, I need to write angular momentum operator in spherical polar coordinates. So in this class, I'm going to represent angular momentum into spherical coordinate systems. And what we know, what is the spherical coordinate system? So you have x-axis, you have a y-axis, you have a z-axis. You call this is point P, R, theta, phi, and you call this is a theta, and you call this distance, this angle is phi, and this vector, if you say this vector is R, so this vectors become perpendicular to this here, this vector becomes R sine theta. And you can write x value, x is here for you r sine theta cos phi, r sine theta cos phi, y is r sine theta sine phi, sine theta sine phi, and for z for you is r cos of theta. Now once we know these relations, now we can calculate the representation of angular momentum operator in the spherical coordinate system. So let us do it now. So what we know that our L is what? L is your R across P. And I can write L. So you have P is my minus iota h cut del, and del operator I can write as del upon del R plus theta cap plus r del upon del theta plus phi cap r sine theta del upon del phi. This is my del operator. And r, vector r, how can I write? Vector r can be written as a unit vector r cap into r, magnitude r. So when r multiplied with this del operator, this r cap term will become 0. So now what you have L, you left with L minus iota h cross, and now you're multiplying r with this one 0, r cancel, and r cap multiply by theta cap, phi cap del upon del theta. This is your first term, this has become 0, and now r cap multiplied by phi cap, you get minus theta cap r cap into phi minus theta cap. So this is like a orthogonal system like ijk. Same way here, when you multiply r cap with theta, you get phi. When you multiply r cap with phi, you get minus theta cap. And now r cancels, so you have a sine theta here. You have a sine theta here. And then you have a del upon del phi. So this is representation of angular momentum operator in spherical polar coordinate system. So now here you say r is not present here. Now I want to write the component of L, Lx, Ly, and Lz. So for that, what I need to express this phi and theta cap in terms of ijk. So how to do it? Let us proceed now to transformation of these unit vector in terms of ijk. So for that we have say r. How do I write r? So r can be written as a I cap x plus j y j cap y plus k cap z, and now x I have. So I cap is r sine theta, x is r sine theta cos phi, and j is what? J cap, y is your r sine theta sine phi, and you have a k cap. This is your r cos of theta. So now I have r. Now I want to find theta cap. So how to write now theta cap? So theta cap is a unit vector in the direction of theta. So if I have a vector which is in the direction of theta, and if I divide it by its magnitude, I can get the theta cap. So what I do, I find a vector gradient in the direction of theta, the variation of r in the direction of theta. So this become a vector, and now if you divide this vector by its magnitude, this becomes theta cap. So in order to find theta cap, I want to differentiate this equation with respect to r. Similarly, if I want to write the phi cap, the phi cap will be del r upon del phi divide by its magnitude del r del phi. So let us write first theta. In order to calculate theta, let us find out del r upon del theta. So del upon del r theta, differentiate this equation with respect to theta. So you have r sine theta become cos theta, and then you have a cos phi, and this is my I cap here, and then you have a j sine theta. Again you have here sine theta, that will become cos theta. So you have a j r sine theta become cos theta sine phi, and then you have a cos theta. So this become minus k cap r sine theta. And now the magnitude of this one, if you calculate the magnitude of this one, del r upon del theta, it will come r, because it is under root. This is under root r square cos square theta cos square phi cos square theta sin square phi. So if you take cos square theta common, cos square phi sin square phi become 1, and now you left with only r square cos square theta, and here you have r square sin square theta. So r will come out, r will come out, and cos square theta plus sin square theta can become 1. So the magnitude is r. So now what I can write? So I can write now the theta cap. Okay, let me write now theta cap. So theta cap I can write here. So theta cap become divided by r, means this r will be cancelled out. So you have a cos theta cos phi I cap, and then r cancel. You have a cos theta sin phi j cap, and finally you have kr cancel. You have a k sine of theta. So this is my theta cap, cos theta cos phi, cos theta sin phi, and minus sin theta. So it's correct. Now let me write phi cap. Let us calculate now phi cap. So for phi cap, first let us find out del r upon del phi. So del r upon del phi, if you differentiate cos phi with minus sin phi, so you get minus minus r sin theta, doing partial differentiation, sin phi I cap, and then you have a here sin phi, so this become plus r sin theta, sin phi become cos phi differentiation j cap, and r cos theta with respect to phi becomes 0. So this is my del r upon del phi, and phi cap, we have to divide this by magnitude, and magnitude r sin square theta, r sin theta will come out common, sin square phi cos phi become 1. So that will be divided by 1 by r sin theta. So this becomes my simply sin phi I cap, and you have a cos phi j cap. The simple minus sin phi plus cos phi j cap is the expression for phi. So I have everything now. I have theta cap, I have phi cap. Just put it here and you'll get the components of L. So L is minus iota h cross phi cap is this one. So you have minus sin phi I cap plus cos phi j plus cos phi j, and you have del upon del theta. This is, and now you want to write theta cap. Theta has a three terms. So you have cos theta cos phi I cap. So I'm writing here, and then you have a cos theta sin phi z cap minus k sin theta, and this whole is divided by what? Sin theta, and then you del upon del phi. So 1 divided by sin theta del upon del phi. So this is my L. So now let me simplify it. So now I want to gather terms of I and J, okay, so that we can solve it. Now let me calculate the Lx, okay. So because we have L is what? L is your iota Lx J Ly plus K Lz, okay. So if I take all I terms, I can write the Lx, J terms will give you Ly, K terms will give you Lz. So let me write now Lx first. So Lx will be what? Lx will be minus iota h cut, and then you have a sin phi minus sin phi. So minus sin phi, and here minus sin phi and del upon del theta, del upon del theta. Minus iota h cross minus sin phi del upon del theta, and here you have a cos theta divided by sin theta cot theta. So you have a this is also minus. This is also minus is here. This is a minus here, and this Lx should be also minus. Okay, Lx should be also. Let me check it. This is a minus. This will be minus. Where I'm here. I'm here. Cos theta, cot theta, cot theta, cos phi, and then you have a del upon del phi, del upon del phi. This is your Lx. Similarly, you can write for Ly is minus iota h cut. You have a, instead of sine phi, now you have a cos phi, del upon del theta here, and now you have this is cos theta minus will become minus this term cos theta sine phi and divided by sine theta. So this become cot. So this become cot phi. So this become cot theta sine phi, and then you have a del upon del phi. So this become your Ly, and now you have a last Lz. So Lz only you have terms k term. So here k term is not there. Here only k term is there. Sin theta cancels out. So you have only minus iota h cross, and inside you have this minus plus. So you have only del upon del phi. Del upon del phi, that means minus iota h cross del upon del phi is the Lz. Okay, so we have calculated Lx, Ly, Lz. Okay, from there, now I want to find L square, and we also, so once we have Lx, Ly, you can easily write the values of ladder operator. Ladder operator is what? Ladder operator is your L plus minus Lx plus minus iota Ly. So we can find out from the ladder operator here. And now I need to find the L square. For L square, I need to calculate the L plus and L minus also. Okay, that we will do in the next class. I'm stopping here. Thank you very much.